PU2 aspirants. So in today's video we are going to solve model paper 2. Okay, so I have already solved model paper 1 and model paper 3. So if you haven't watched those videos, you can go and watch, and I'll tell you that out of the 3 model papers that was released by PU board, I felt model paper 2 was little bit on the tougher side. Why? Because the questions asked here were little uncommon and I can say out of the box questions. Some of them were there. So definitely this makes the question paper a bit tricky, and it also tells us that the question paper we cannot expect only direct questions or only those questions which have been asked from last 5 to 10 years, but yes, this year there can be a change and there can be some different questions as well. Okay, so yes, let's get started now. So please sit with the notebook and a pen. I want all of you to solve the model paper 2 first by your own, and then come and watch this video to understand the solutions. Okay, I'll be telling you how you should be writing the answer, what is the marking scheme, everything will be discussed. Okay, so now moving to the question pattern, all of you know about this. So 1 to 15 will be your MCQs, 1 marker, 15 questions, all are compulsory here. 16 to 20 will be your 5 marker questions, 5 F fill in the blanks will be there, sorry FIB fill in the blanks 1 marker question. Then 21 to 25 will be 2 marker questions, 5 questions will be there in which you have to attempt any 3. Okay, so this one will give you 15 marks, this one will give you 5 marks, this one will give you 6 marks. Next we have question number 26 to 34. So it includes 3 marker question. 3 marker question has 2 sections from inorganic chemistry and from organic chemistry. So total you have to write 5 questions. So I can write 5 out of 9, and this one will give you 15 marks here. Next question number 35 to 40 is your 5 marker question, and this is mostly from your organic chemistry, and here we have 6 questions in which you have to attempt any 4 and you can get 20 marks here. Now coming to question number 41 to 46, these are your numerical questions. Okay, and each numerical is 3 mark. You will have 6 questions and you have to attempt any 3 and you will get 9 marks here. Okay, so now if I add 15, 5, 20, 40, 50, 55, 55 plus 6, 61, 61 plus 9, 70 marks total. Okay, fine. Now let us go to the section A, 1 marker question. Now the square planar complex of the type MABXL shows dash. How many types of isomers are there? Now this one I will mark it as a difficult question, although it is there directly in your book, but yes, still I find that many of you might not be knowing this one. So when you have this one, you should mark like this. See, you should imagine that A, B are one type of ligand, means they can be halogen group or they are like belonging to the same category. So A and B, first if I keep like this, it is trans and I have X and L. Okay, so this is one form of trans. Now I can have another type where A and B are in cis. Okay, and I will put this X opposite to A and L here. Okay, this is one cis, and another way I can put here is M A B. Okay, and I keep L opposite to X. Okay, so this is also cis. Clear? So you can find we have 1 trans and 2 cis forms. So basically you have to find that this you have to fix 1 ligand and you have to keep all the other 3 ligands opposite to A one time. Okay, so you will get 1 trans and 2 cis. So that is why the correct answer here will be option number A, 2 cis and 1 trans. Okay. Next, the order of the reaction in which the unit of the rate of the reaction and rate constant are same. So the question is asking unit of rate of the reaction and rate constant are same. So if I write any rate law, rate is equal to K into AN, right? This is the rate law. Now the question is saying in what order reaction the unit of rate and the rate constant will be same. So if I just remove this part, okay, then rate and rate constant will be equal, their units will also be equal. How can I remove this one? If I put n is equal to 0, then what I can write? Rate is equal to K into A to the power of 0 and rate is equal to K. right? So I can say that for 0th order reaction, rate is equal to rate constant. So the unit of rate and rate constant will also be equal. Answer will be option number A. Okay, this one I can mark as a moderate question. Okay, so it is not very difficult, but yes, you have to think a bit. Okay. Next, statement question. Statement number 1 is tertiary alcohols heated with copper at 573 Kelvin yields 2-methyl propene. So tertiary butyl alcohol, tertiary alcohol, suppose I have like this, okay, and when you heat it with copper at 573 Kelvin, okay, here OH and H will be removed and we get this one. Okay, so that is the first thing. Next, tertiary alcohols undergo dehydration reaction when treated with copper at 573 Kelvin. So yes, because we are removing OH and H, it is undergoing dehydration reaction to give you this alkene. So both statement 1 and statement 2 are correct. So the correct answer for this question will be option number A. Okay. Next, question number 4. The tanks used by most scuba divers are filled with air diluted with helium of around. I will again mark this question as difficult. Okay, why I'll tell you. See, this is very direct and fact based question. There is nothing to use your brain in this question. But yes, if you haven't studied, it is something which you have to memorize, right? If you haven't memorized the composition of the oxygen tank properly, then you will definitely get confused here. So please remember, helium is 11.7%. Okay. Next, 1,2-dichloroethane is an example of. So if I have write down this one. The options, I'll say the options are really tricky here. If I can see this, I will immediately, I know that these are vicinal dihalides. Okay. But you see in the option there is no vicinal dihalides. Why? Because there is other name also given to vicinal dihalides and we call them as alkyline dihalides. Okay, so again I think this question is also on the difficult side because many of you will be knowing that it is vicinal dihalides, but you may not be knowing this one as alkaline dihalides. So please remember, it is vicinal dihalides are called as alkaline dihalides, and alkylidin, you can see the difference here, one D comes, is for Zem dihalides. Okay. Okay. Next question. A galvanic cell has an electric potential of 1.1 volt. If an opposing potential of 1.1 volt is applied to this cell, what will happen to the cell reaction and the current flowing through cell? This question we also, I think, is little bit on the moderate side, not very easy, because we have studied that if external potential is more than 1.1 volt, then it will behave as an electrolytic cell. This many of you might be knowing. But if you see the option, the reaction stops and no current flows through the cell, the reaction continues but current flows in the opposite direction, the concentration of reactants become unity and current flows from cathode to anode, the cell does not function as a galvanic cell and zinc is deposited on the zinc plate. So the answer here is the reaction stops and no current flows through the cell. Okay, that is what happens when you give an opposing potential of 1.1 volt. Next, as the size of the aldehyde molecules increases, the order becomes. This one also I will mark as a difficult question, because generally in physical properties we give more importance or we understand more about solubility and melting point and boiling point. But regarding fragrance, most of you might not have put that much attention, but yes, you can see. So here the answer will be, it will be less fragrant. Okay, the smaller the molecules, it is more fragrant, and when the size increases, it becomes less fragrant. Okay, I have discussed this in my Decode NCERT series, but yes, if you haven't known, please note it down. Next, question number 8. Sulfur containing amino acid is. So this one is your cysteine, and this one I will also mark it as moderate, because all of you do not remember the amino acids very easily. Okay, but remember sulfur containing is cysteine. Next we have, yes, this is also for me a moderate question. I cannot mark it as easy question. The CO bond angles of P, Q and R are found to be 111.7, 109, 108 degree respectively. Compounds P, Q, R, R dash. Okay. So if you can see here, options, phenol is there, methanol is there and methoxymethane is there. So I can say we have one phenol, okay, P is phenol, and sorry, I have one phenol, I have one alcohol, that is methanol, CH3OH. Okay, I'll write it in the structure so that we can find the bond angle easily. Okay, this is phenol, this is methanol, and we have methoxymethane. Okay. Now if you see here, I have two bulky groups, right? So these two bulky groups will repel each other and this bond angle will increase, right? Now if the bond angle will increase, so I can see that 111 degrees Celsius is this one. Sorry, 111 degree Celsius. So this is my P, right? So P is equal to methoxymethane. I have two options. I can eliminate this two. Okay. Okay. Now if I compare here, again this is a bulky group, right? So this bulky group and this will have some repulsion, and here there will be less repulsion, right? So this angle will be the smallest and this one will be middle one, middle value. So if you see, out of this, the smallest one is 108.9 degree and this one has to be 109 degree. So I can say that this one, Q is phenol and R is alcohol. So Q phenol and R alcohol. So that is your option number D here. Okay, this is also a very difficult to moderate question. You should be knowing the proper concept. Yes, this one I can tell as a easy question, not much difficult. Just you have to find out rate law, right? Following results are obtained. Choose the correct option for the rate equation of this reaction. Now if I want to find the correct order, so you can see first, suppose let me assume that rate is equal to K into A to the power of X, B to the power of Y. Now if I want to find A value or X value, I have to keep B constant, right? Now in which reactions B is constant? So B is constant in first and third reaction, right? So I can say that from first to third, what is happening? Okay, B is constant, right? So first, what is happening to A? I am doubling the concentration of A, 0.4 to 0.8, and at that time what is happening to this one? This is also becoming double, right? This is doubling, this is also doubling. So that means what? When you increase the concentration or when you double the concentration, the rate is also becoming double. That means it is a first order reaction. So I can say that with respect to X, it is 1, or I can say first degree of first order reaction. Now to find B, I'll keep A constant. I'll keep this one as constant. Now here to here, what I can see, I have doubled the concentration and here it has become 4 times. See, you have doubled here and here it has become 4 times, right? So when you double the concentration and the rate become 4 times, then I can say that it is a second order reaction. Okay. So the rate is rate is equal to K into A to the power of 1 and B to the power of 2. Okay. So that is your option number B. Clear? Next, question number 11. The reagent useful for the separation and purification of aldehydes. Again, this question is also difficult. See, if it is asked only separation, we can identify, but purification is also included there. So you know that using sodium nitrate, so that is your silver nitrate solution, that is your Tollens reagent, and Fellings reagent, what you can do? Let me not put tick mark, it will confuse with the answers. See, if I use this one and this one, what I can do? It can use to test aldehydes, but not for purification. Okay. So that is why we can cancel A and C. Now sodium hydrogen sulfide, what does this do? You see here. when sodium hydrogen sulfide forms a stable crystalline bisulfide addition compound with the aldehydes. Okay, it forms a addition compound with aldehydes, and this help in the separation and purification of aldehydes from the mixtures. Okay, so that is why we can not only separate but also purify them. So that is why correct answer for this question will be option number B. Okay. Next, yes, this question is also difficult. I will say MCQs of this particular paper is very difficult because you can see the questions are not easy. You have to remember everything to answer these questions properly. Now, when this type of matching comes, first you do whichever you know, then you can eliminate the option. Like for example, I know thyroxine will cause what? Iodine deficiency, and iodine deficiency can lead to goiter. So it will be 4 will be D. So for D I have 2 options, so I can eliminate this one. Okay. Next, if you see halothane, halothane is used as an anesthetic, so 3 has to be B. So if I see here 3 is B and here 3 is C, so I will eliminate this one. The correct answer here will be option number B here. Okay. Next, if I see the other options, chloroquinone is for malaria, so 2 has to be A. Okay, and chloramphenicol is used for typhoid fever or any bacterial infection, so 1 has to be C. So correct answer is option number B here. Okay. Next, yes, this question I can say was easy. Okay, this is an easy question. Okay, so first of all, CN is there and lithium aluminium hydride is there. It is a reducing agent. So what I will get here? I will get first thing, that is CH2 NH2. Now after that, when you treat it with CHCl3 and NaOH, this is your carbyl amine reaction. So what I will have? CHCl3 with NaOH, carbyl amine reaction, right? So this primary amines get converted to isocyanates, right? And they gave a foul smell to us, and we can easily detect the primary amines in this case. So correct answer for this one will be option number C. Next, the magnitude of CFSE can be related to the configuration of d orbitals in a coordinate entity is. So here you remember, if delta O is less than pairing energy, okay, delta O is less than pairing energy means this gap is very less. Okay, this gap is very less, and what will the electrons do? They will go to the higher level. Okay, there will be no pairing here. And if delta O is greater than pairing energy, means this gap is very high, then what will happen? Electrons cannot jump to such a higher level of energy orbital, they will start pairing here. Okay, so what I can say here is, you should remember like this, just a minute, yes. So if delta O is less than, then we have no pairing of electrons. Okay, and if delta O is greater than P, then we have pairing of electrons. We have pairing of electrons. Okay, so now if you see, I have this one. If delta O is less than P, means there should be no pairing of electrons. The configuration for, okay, the configuration is asked for D4. Okay, so you can see here, if there is delta O is less than P, then there is no pairing, and we will have T2G3 and EG1. So this is correct. Okay. Next, if delta O is greater than P, means very high splitting, then there will be pairing of electrons will take place, and in that case we will have T2G4 and EG0. So it is given the wrong one. Next, if delta O is greater than P, again the splitting is very high. In that case the configuration is T2G2 EG2. No, this is also completely wrong. If delta yes, if delta O is less than P, then also we are doing here pairing, so this is also incorrect. So correct answer is option number A here. Next, the correct order of melting point is, this question also I will say little bit on the moderate side. Okay, this one I didn't mark, this is moderate, I can mark it as easy. If you have understood the concept, then this is easy. Okay, next, melting point. So generally what happens along the period, okay, see, along the period number of unpaired electrons increases and then decreases, right? So if the number of unpaired electrons will increase, what will happen? Metallic bonding will increase, metallic bonding will increase, and for that reason melting point will increase. Okay, so what happens exactly is, if you go along the period, there is first increase and then decrease, metallic bond will first increase and then decrease, and melting point will first increase and then decrease. Okay, so what happens here is, we find a table like this. From scandium, titanium, vanadium, chromium, up to chromium the melting point increases. Then at manganese there is a dip. Now what is the reason for this one? Manganese has a stable D5 configuration. Okay, it has unpaired electrons but does not participate in metallic bonding, does not participate in metallic bonding. Okay, it does not participate means its melting point will be less. So obviously manganese will be least, and we have only one option like that. Okay, after that it again increases. Okay, after that it again increases and then decreases. So I have scandium, so chromium will be highest, then I have iron, and then I have manganese. So option number C is the correct answer here. Okay, this one is moderate. If you know this trend properly, then easily you can answer. Okay, now coming to the fill in the blanks question. The storage polysaccharide present in the animals is, this is very easy, glycogen, right? In plants it is starch. Vitamin B12 is a coordination compound of, so vitamin B12 contains cobalt and it is also called as cobalamin. Okay. Next, primary aliphatic amines converted into aliphatic alcohols on reacting with dash solution. So if I read it with nitrous acid, okay, then it will get converted to alcohols. Okay, so 16th, 17th and 18th is done, and I have used these things. So to confuse here, both glycogen and starch is given. So remember, starch is a storage polysaccharide for plants. Okay, next, chemical name of wood spirit, that is your methanol. Okay, it is methanol. Next, change in the standard Gibbs free energy of a reaction is does not altered by the addition of. Okay, so sorry, if you add a catalyst, then there is no change in the equilibrium constant as well as in the Gibbs free energy, we all know that. So correct answer is catalyst. Okay. Now we'll go to section B, 2 marker question. So if you remember, here the pattern is like this. You will get 5 questions. And what are these 5 questions? These questions can be from solutions or chemical kinetics. Okay. Next, you can have one question from coordination or D&F block. Then one question from haloalkanes, one question from alcohols, and one question from biomolecules. Okay. And these 5 questions you have to attempt any 3 out of 5. Okay, so let us see the first question. The first question is from your solutions chapter, right? Okay, so this is very simple. Draw a graph to show the variation of vapor pressure of solvent and solution with respect to temperature. So I can say this question is difficult. Okay. Why? Because directly the graph is not given in the textbook with the same terms used. Okay, and very few of us actually observe what is there in x-axis and what is there in y-axis. If the question is given to you as draw the graph for the change in the boiling point of the solution and the solvent, then all of you will be able to do it. So here basically the question is asking you to draw this particular graph where we show the elevation in the boiling point. So if you see here, x-axis is temperature and y-axis is vapor pressure, and vapor pressure of the solvent will be more and solution will be less. So that you have to show here. Here this boiling point and all, this is not mandatory to show, you just have to draw this one and then this one and then this one. Okay. Okay, next, explain the preparation of methoxymethane by Williamson ether synthesis. Give equation. So this question is from your alcohols chapter, right? And I can mark this one as a easy question because direct name reaction question. But you have to explain with respect to this particular example. Methoxymethane means what? CH3O C2H5. Now we know that any ether is formed of one RX and one R-ONA, right? Now here if you see which one will be Rx and which one will be R-ONA, if you can find out that, then this is a very easy question. So always remember the Rx should be less sterically hindered one, or I can say less sterically hindered or a smaller group one. Okay, so if you see here I have CH3X. Okay, so I can take this one as CH3X1 and I have C2H5ONA. Okay, so this one can attack here, this one will go out and we will get this one as the product. Okay, how can I write this one? Methyl chloride. So I have taken CH3Cl on heating with sodium ethoxide. Okay, in alcoholic media gives methoxymethane. This reaction is called as Williamson ether synthesis. Now if I have to write the reaction also, so I will write like this: CH3Cl plus C2H5O minus Na plus gives, this one will come here, Na and Cl will form a bond, so I will get CH3O C2H5 plus NaCl. Okay, clear? Now let us go to next question number 23. What are heteroleptic complexes and what is the coordination number of the complex COOX whole 2 Cl2 plus? Okay, so this question also I will mark as moderate because the first part is no doubt very easy, but this part many of you may get wrong. Moderate question from the chapter coordination. Okay, so first of all, heteroleptic complexes are those complexes which has more than one type of ligand, right? So yes, so you can see a heteroleptic complex is one in which the central metal atom is coordinated to different types of ligand. Example you can write down, if you don't remember anything you can write down this same example or any other example. Now coordination number here. So if you remember, oxalate is didentate. That means what? Each oxalate forms two bonds. Okay, if I have two oxalates, it will form 4 bonds. Okay, then I have 2 chlorine. Chlorine is monodentate, means each chlorine forms 1 bond. So 2 chlorine will form 2 bond. So total how many bonds are there? So the central metal atom is forming 6 bonds. So its coordination number will be 6 here. Okay. Next, question number 24. Chlorobenzene cannot be prepared by reacting phenol with SOCl2. Give reason. Now generally what happens? If I react like this, ROH plus SOCl2, I get RCl. Right? This I get. Now what is exactly happening? This OH group is replaced with this Cl group. Right? But the question is saying that if I have anything like this, phenol, and I treat it with SOCl2, then is this reaction possible? You just replace this OH with Cl. No, this reaction is not possible. What is the reason for that? So this is again I can say a moderate question, because the most easier version of this question which was asked from past years is haloarenes are less reactive towards nucleophilic substitution reaction. Give reason. If this question is asked, I know many of you can answer this because it is very direct question, but this is somewhere you can say on the application side or directly when application is taken and asked in the question. So that is why I will be telling you the answer. The answer for this one and this one will be same. Okay, so do not worry. But yes, you have to frame it in a little bit different way, that phenol does not react with thionyl chloride to form chlorobenzene due to the following reason. The first reason is the strong CO bond in phenol. So this is phenol, right? This is phenol, right? So in phenol what happens, we have lone pair, these electrons come here and a partial double bond is formed, and this carbon to oxygen bond is very strong, okay. So you can see the CO bond in phenol has a partial double bond characteristic due to resonance, okay. This makes it very strong and resistant to the cleavage by SOCl2. So that is why, because of this partial bond, this bond is very strong and cannot be broken easily. That is the first thing. Second one is this hybridization of this carbon. This is sp2 hybridized carbon, and whenever we have a sp2 hybridized carbon, it forms a very strong bond again. So yes, in phenol the carbon is sp2 and holds the CCl, here is a small mistake, holds the COH bond more tightly, okay. So this bond is very tight and hold properly because of the sp2 nature of this carbon. So thus phenol cannot be converted to chlorobenzene using SOCl2, okay. Next, what are hormones? Name a hormone that mediate the response of external stimuli. Again I will mark this question as difficult, okay, because many of you might not study hormones very seriously, because that is a very small part and often a neglected part. From biomolecules you focus mostly on proteins and carbohydrates and sometimes on nucleic acids. So I will be telling you the answer here. First, hormones are what? These are intracellular messengers and are secreted by the endocrine glands. They are poured directly into the bloodstream, okay. Now coming to this part, the hormones that mediate the responses of external stimuli. So you should be knowing the hormones and their functions. So epinephrine and norepinephrine are those hormones which stimulate the external stimuli, okay, or which is responsible for the responses to external stimuli, okay. So I can see that if you find question number, I think you have to attempt any 3, right? You should be doing question number 2, obviously, that is easy. Question number 22, 23 and 24, okay. I think 22, 23 and 24 should be the one which you can attempt more easily than 21 and 25. Now we will go to 3 marker questions. So here I will be telling you how the pattern is there. So it is like 2 sections are there. The first one is your inorganic part, okay. Here you will get from coordination and D and F block, and the next one is physical part, and in physical part you will get questions from 3 chapters, that is solutions, electrochemistry and chemical kinetics, right. So from solutions 1 chapter, from solutions 1 question, electrochemistry 2 question and chemical kinetics 1 question, okay. Okay, so let us see the first part here. So this question was, I can say, a very good question and very easy question, but it is again framed in a different way to confuse you. If the direct question is given like, write the preparation of K2Cr2O7, then all of you can write it, but it is given in a different form. So when a chromite ore A is fused with sodium carbonate in excess of air and the product is dissolved in water, a yellow solution of compound B is formed. After treatment of this yellow solution with sulfuric acid, compound C can be crystallized from the solution. When compound C is treated with KCl, orange crystals of compound D is crystallized out. Write all the reactions involved in the conversion of A to D, okay. Okay, so if I see here, first of all, the iron chromite, when a chromite ore A, so this is your A, okay, is reacted with sodium carbonate in excess of air and the product is dissolved in water, a yellow color B compound, that is sodium chromate, is formed. After treatment of this yellow solution, that is B, okay, with sulfuric acid, compound C can be crystallized out, which is sodium dichromate. The compound C is treated with KCl crystals and compound D is crystallized out. So this is your compound C, and when it treated with KCl you give compound D here, okay, and all the reactions are given to you. Okay, next write the IUPAC name of the given compound and draw the geometrical isomers of this complex. So if you see here, in the case of writing the IUPAC name, the first thing we do is we have to write the the ligands. So here you can see one ligand is chlorine, one ligand is ethane 1,2-diamine. So which comes alphabetically first? Chlorine will come first because it is starting with C. So we have dichlorido first. Then this type of ligands we use the word bis before that to represent that it is 2. So bis ethane 1,2-diamine. Okay, dichlorido bis ethane 1,2-diamine. Then I have cobalt here. Okay, now if I see cobalt here, then it is X minus 2 is equal to plus 1. X will be equal to plus 3. Okay, clear? Now coming to draw the geometrical isomers for this complex. So I will have like this CO, Cl, Cl, En, En. This is the transform. Okay. Now you can also do the cis one. It is like this. So the question has given you only the geometrical isomers, so you just have to do the cis and transform. So this is the cis one. Now if all the isomers are asked, then the cis form will also have an optical or the mirror image, or so we will have 3 total isomers, but the question is asking about only geometrical isomers, so cis and trans we have to draw. Okay, so this carries 1 mark, 1 mark and 1 mark, total 3 marks. Okay, next, fluorine has the ability to stabilize most of the transition metals in higher oxidation states. Give 2 reasons with an example. Again, this is a very, I can say, what I can say, if I take the level, okay, I can say this is moderate, because many of you can also be able to guess, I think. This is also moderate, not very easy, but I think this one is little bit on the difficult side, because they have also told you to explain with an example. So we might not have studied the example properly, so very important study here. The ability of the fluorine to stabilize the higher oxidation state is due to, there are 2 factors in this, either higher lattice energy, okay, either due to higher lattice energy. Now the example for this higher lattice energy is COF3, or higher bond enthalpy. For terms for the higher covalent compounds, example VF5 and CRF6. Clear? So we have basically 2 factors, that is, one is higher lattice energy and the other one is higher bond enthalpy. Okay. Now higher lattice energy, I have one example COF3, and bond enthalpy I have VF3 and COF6, right? VF5, sorry, this is VF5. So this is what you have to write, 2 factors and 1 example for each factor. Okay. Next, write any 3 limitations of VVT. This I think is also easy question. Or I can also write it moderate, because generally from coordination chemistry we expect one question which is very common is your the hybridization, geometry and the magnetic property of CONH3 6, so that 4 compounds, but that question has not been asked. Limitations of VVT is basically asked here. So here we have given you 6 limitations, you can write any 3. The first one is, it does not, sorry, I have given you 5. It does not give any quantitative interpretation of magnetic data. So very easily you can write down, it does not give any information about magnetic data, does not give any information about the color of the compounds, does not tell anything about their stability. Okay. Next is regarding, so you can write down any of these 3 points, does not distinguish between weak and strong ligand. So I can see that 1, 2, 3, 4, these 4 points you can easily remember. Now 5th one is, it does not make exact predictions regarding the tetrahedral and square planar structures of 4 coordination number complex. Okay, so that is the problem here, but yes, you can write easily. It is like color, magnetic property, stability and the strong and weak field ligands. Okay. Next, is what is lanthanide contraction and name two elements of actinoids which exhibit +7 oxidation state. This one I can say as a easy question because many of the paper this questions was there. Okay, sorry. What is lanthanide contraction? All of you will be knowing the gradual decrease in the size of the lanthanides along the period due to the poor shielding of 4f orbitals is called as lanthanide contraction. Apart from this, you should also be studying the consequences of lanthanide contraction and the cause of lanthanide contraction. Next, the two elements which exhibit +7 oxidation state is your NP and PU. Okay. Now we will go to the 3 marker questions from the physical chemistry section. The first question is, what is the effect of temperature on the rate constant of a reaction? How can this temperature effect on the rate constant be represented quantitatively? Okay, so very easy question. So if you know what happens, when you increase the temperature by 10 degrees Celsius, the rate of the reaction of the rate constant becomes double, right? And why does this actually happen? When we increase the temperature, the number of molecules having energy greater than the activation energy increases. So that is why the rate of product formation also increases. This is very well explained in your Boltzmann distribution curve, right? So that you have to mention in the first part. And which equation tells you about the temperature effect? That is your Arrhenius equation, and you have to mention all the terms in the Arrhenius equation. Okay. So if I see here, you can see the rate constant increases with an increase in temperature. For the rate constant doubles on increase the temperature by 10 degree. Now why does this happen? When the temperature increases, the fraction of the molecules which collide with energy greater than activation energy also increases, and this leads to a faster reaction. Now quantitative representation, K is equal to A into e to the power of minus EA by RT, where K is rate constant, A is your Arrhenius constant, E is your exponential, EA is activation energy, R is gas constant, and T is absolute temperature. Okay. Next, plot a graph of molar conductivity versus concentration for strong and weak electrolyte in the solution. For strong electrolytes, write the equation that represent the variation of molar conductivity with dilution. So here if you see, the graph is like this. Okay. So if I have molar conductivity on this side and root over of concentration on this side. So what happens? This is for strong electrolyte and this is for weak electrolyte. Strong electrolyte and we have weak electrolyte. Okay. And one thing, yes, this is the graph you have to draw. Next, for the strong electrolyte, write the equation. So we have lambda m is equal to lambda naught m minus a root over of c. Here you can explain the terms also. Lambda m is what? Lambda m, lambda naught m, a and c. Okay, just a minute. Okay. So lambda m is your molar conductivity. Molar conductivity. This is limiting molar conductivity. Okay. And A is a constant and C is your concentration. Okay. Next, question number 33, write the 3 reasons to justify that osmotic pressure method has an advantage over other colligative properties. The first advantage here is you can calculate osmotic pressure at the room temperature. Second is it uses molarity instead of molality. And third one is the values here are very big, which is easy in the calculation. The difference is the osmotic pressure comes out to be very big numbers, which we can use very easily for the calculation. Okay. So 3 advantages are here. In this case, molarity can be measured at room temperature. The magnitude is large as compared to the other colligative properties. Okay. Next, yes, during the working of a Leclanche cell, that is a dry cell, write the anodic and cathodic reaction. Right, what does What is the role of the produced ammonia during the cell reaction? So if you write first the reaction, zinc undergoes oxidation and MnO2 undergoes reduction to give you this compound. Now whatever this ammonia is formed, it forms a complex with this Zn2+. That is the role of the ammonia. Ammonia produced in the reaction forms a complex with Zn2+ to give you ZnNH3 2+ ion. Okay. Okay, now we'll go to 5-marker question. So here we have total 6 questions, 1, 2, 3, 4, 5, 6. The first question, like one question will be from haloalkanes, next question will be from alcohols, okay. Then 2 questions will be there from aldehydes. Then we have aldehydes, ketones and carboxylic acid. Next question is from amines and next question is from biomolecules. Okay, and you have to attempt any 4 out of 6 here. Okay. Now the first question here is give any 2 differences between amylose and amylopectin. You can see here the first one, it is water soluble and water insoluble. So both amylose and amylopectin are a part of a starch, right? Next, in amylose it is 15 to 20% of the starch, it is 80 to 85% of the starch. This is water soluble, okay, this is unbranched chain and this is branched chain. Then you have to tell about the linkage. So here alpha D glucose units form C1-C4 linkage, and here the alpha D glucose units in which the chain is formed by C1-C4 glycosidic linkage and branching occurs at C1-C6 glycosidic linkage. Okay. Next, name any 2 forces which stabilize the secondary and the tertiary structure of protein. So we have different forces here like hydrogen bonds, disulfide linkages, van der Waals and electrostatic forces of attraction. Okay. So you have hydrogen bond, disulfide bond, van der Waals force and electrostatic force of attraction. You can write any 2 here. Next, which vitamin deficiency causes the increased fragility of RBCs and muscular weakness? That is your vitamin E here. Okay. So this is the 5-marker question from biomolecules. Okay, next from aldehydes, ketones and carboxylic acid, write the mechanism for the addition of HCN to carbonyl compounds in the presence of the base. Aromatic carboxylic acid does not undergo Friedel-Crafts reaction, give reason. Okay, so mechanism is very simple here. So first of all, what happened, HCN reacts with one OH minus. This is a base, it takes this proton and we get H2O and Cn minus. Now the Cn minus can attack on a carbonyl group to form a tetrahedral intermediate. Now from the medium this takes H plus to give you cyanohydrine. Okay, so that is the mechanism. 1, 2 and 3 steps, 3 marks. Next, why do aromatic carboxylic acid does not undergo Friedel-Crafts reaction? So the aromatic carboxylic acid do not undergo Friedel-Crafts reaction because the carboxyl group is a deactivating and the catalyst aluminium chloride, that is a Lewis acid, gets bounded to the carboxyl group. Okay, so what happens here? First of all, the carboxylic group, the COOH group, is a electron withdrawing group, so it is a deactivating group and also it forms it reacts with the aluminium chloride present in the Friedel-Crafts reaction. Okay, so 3 plus 2, 5 marks. Next, explain Hoffmann bromamide degradation reaction by using butanamide as an example. Give the IUPAC name of the product. Okay, pKb of aniline is more than that of methanamine, give reason. So here you can see explanation 1 mark, example 1 mark and IUPAC name 1 mark, 3 marks here and this one carries 2 mark here. Okay, so you have to write 2 reasons here. So first of all, amides on heating with Br2 or aqueous NaOH gives you primary amines. This reaction is called as Hoffmann bromamide degradation. You can write a basic reaction mechanism, but it has told you to write with butanamide as an example. So you have to write by taking butanamide. So 1 second, just a minute. Okay, so I can write the reaction here, CH3 CH2 CH2 CONH2. Okay, if I heat it with bromine and NaOH, this part will go and I will get CH3 CH2 CH2 and NH2. Okay, so IUPAC name of the product, so this is your propanamine. Okay, so basically you don't have to write this general reaction, you can just write down the definition and this example and the IUPAC name. Next, why is aniline pKb is more? Now, if the pKb of aniline is more, that means what? It is less basic. Less basic means what? It is not able to donate its electron. So, the very simple reason for that is, if you see the structure of aniline, I'll tell you how to write, but I'll explain first. This lone pair is there. Now, if this lone pair can be donated, then it will be called as a very good base. Now, what happens? This lone pair of nitrogen is in resonance with the ring. Okay, it is in resonance with the ring. So, what happens? This lone pair is not available for the donation. If it is not available, the basicity is less and pKb is high. Now, for example, it is donated. If at all it is donated, then what will happen? Conjugate. This is an base, right? So, if I get its conjugate acid will be like this, it will donate this electron to this H plus and we will get now NH3 plus. Now, if this NH3 plus is more stable than this one, then it is a stronger base, right? If you remember, if conjugate acid will be more stable, then the base will be a stronger one. But if I see here, we have only 2 resonating structures, where here we have 5 resonating structures. So, obviously, this one is more stable, because we know more is the number of resonating structures, more is the stability. So, if this is already very stable, then why would it go to this position where the stability is less? So, that is also a reason. Because of the less stability of the conjugate acid, the base is a weaker base and the pKb is very high. Okay, so how to oops, sorry, I have erased the first one also. Let me write down here CH3, just a minute. Yes, this will give me propanamine, right? Okay. Now, if I write the reaction here, the answer for the second part you can see here. Okay, pKb value of aniline is quite high because in aniline the NH2 group is attached directly to the benzene ring. It results in the unshared electron pair on nitrogen atom to be in conjugation with the benzene ring, and thus making it less available for protonation. Okay. Next thing, what? The conjugate acid formed, that is your anilium ion, has only 2 resonating structures, okay, while aniline has 5 resonating structures. Therefore, aniline is more stable than anilium ion. You can also see the resonating structures here. Okay, aniline has 5 resonating structures, whereas anilium has only 1. Okay, sorry, has only 2. So, this is more stable. So, if this is more stable, it will stay in this particular form, it won't get converted to this form. Okay. Next, question number 38. How do you prepare phthalimide from the aromatic dicarboxylic acid? Give equation. Okay. Next, complete the following reaction. This carries 3 marks, this carries 2 marks. 2 A and B you have to guess. So, this I can say a little bit tricky question. So, you can see the answer here. Dicarboxylic acid react with ammonia to give ammonium salt, which on further heating at higher temperature gives you amide. So, this is this part. How do you prepare? Wala, it's statement part. Next, you have to write the equation. So, you can see here dicarboxylic acid, when it reacts with ammonia, it forms salt. Then by heating it with this one, we get amides. Then once this amide is formed, then there is a strong heating and you can get phthalimide here. Okay. Now, next one, with benzaldehyde, if you treat hot concentrated NaOH, so this will undergo what? Cannizzaro reaction, right? Cannizzaro reaction. So, what will this give you? A formed here will be COO minus Na plus, and the other one will be your oxidized product and one will be your reduced product, right? So, you can write this one as A or that one as anything is fine. So, this is your Cannizzaro reaction products. Okay. Next, question number 39 here, an alkene X reacts with H2O and H+. So I have an alkene here X whose molecular formula is C3H6 and it reacts with what? H2O and H+. to give a compound Y. Okay. Next, the compound Y further undergo reaction with CrO3 and H2SO4. Okay, to give or produce compound Z. Now write the IUPAC name of the compound X, Y and Z. So C3H6. So I have CH3, CH double bond, CH2. Okay, this is your X. H2O H plus if you treat, that is what? Addition of water following Markovnikov's rule. OH will be added here. So I will get CH3, CH, OH, H. Next what happens? CrO3 H2SO4, this is your X. This is Y. Next what will happen? This one will undergo oxidation and we will give CH3, CO and CH3. Okay. So this is Z. You have to also write the IUPAC name. So this is propene. Okay. This is propane 2OL. Okay. And this is propanol. Okay. Clear? Next. Which among the following compounds have the lowest and the highest pKa value? So for this one you should be knowing that lowest pKa value will be more acidic and highest pKa value will be least acidic, right? So yes, you can see here lowest pKa will be strongest acid, and if you see para-nitrophenol, phenol, ethanol and orthocresol, so para-nitrophenol is the most acidic one and have the lowest pKa value because it has a electron withdrawing NO2 group which can stabilize the conjugate base. Now if you see all other are phenols, and here we have an alcohol, that is your aliphatic alcohol, that is least acidic and it has the highest pKa value. Ethanol, due to the lack of resonance, stabilized in the conjugate base. So you can see ethanol will have just like this. This is the conjugate base formed here, and this conjugate base is no way stabilized, rather it is further destabilized by the plus I effect of this alkyl group, right? So if it is destabilized, what will happen? The acidity will decrease and it will have a higher pKa value. Okay. Next, question number 40. Write any three differences between SN1 and SN2 and identify A and B in the given reaction. So differences between SN1 and SN2, we have many things. You can write down any 3 points. So you can see here the first thing like reaction order. SN1 is a first order reaction, SN2 is a second order reaction. Number of steps in SN1 is 2, in SN2 it is single step. Intermediate, here a carbocation is formed, here a transition state is formed. Here we have molecularity, monomolecular, and the back and front attack is possible because once the carbocation is formed, it is a planar molecule. Now the nucleophile can attack from the front side also, back side also. So that is why it can have racemization. But here what happens? It is a bimolecular attack, and once the attack is there, it is always from the back side and the product is always a inversion in the configuration. Next, reactivity, it is 3 degree, 2 degree, 1 degree because the carbocation is formed here. So a more stable carbocation is required and 3 degree is very stable. Then here we have 1 degree, 2 degree and 3 degree. Now rate law, if you see here it is first order reaction K into K into the concentration of alkyl halide, and here it is K into concentration of alkyl halide into nucleophile. Order is 2 here. Okay. Next, if I see here, yes, this one NH2 and NaNO2 plus HCl. This is what? This is your benzene disonium chloride. So A will give you N2 plus and Cl minus. Okay, diazotization reaction. Next, here I can just use Cu in presence of HBr to give you bromobenzene. Okay, so this is my B and this is your A. This is your Gattermann-Koch, only Gattermann reaction to get bromobenzene from the benzene diazonium chloride. Okay. Fine. Now we'll go to section E, 3-marker question. So here we have 6 questions, okay, and you will have 2 from solutions, 2 from chemical kinetics and 2 from electrochemistry, and you have to attempt any 3, okay. So how many you have to attempt? 3 out of 6. Let us see the first question. Calculate the mass of vitamin C, ascorbic acid. Its molecular formula is given. Actually molar mass was not given in the question, but I have added, but since molecular formula is given, you can easily calculate the molar mass. To be dissolved in 78 gram of acetic acid to lower its melting point by 1.5 degree Celsius. Kf of acetic acid is given, molar mass is already given, okay. So first let us write down the values that is given to us. So we have here mass of the solvent W2 is 78 gram, okay, and to lower its melting point, that is delta Tf, is 1.5 degrees Celsius. Then I have Kf value as well, 3.9 Kelvin kg mole inverse. Next I have molar mass, that is M2. I can write molar mass of the this is W1, that is solvent, right. W2 we have to find out, and molar mass here is 176 gram per mole. Now let me just write down the formula here. Delta Tf, right, is equal to Kf into M, that is W2 by M2 into 1000 by W1 in grams, right. Now if I substitute, delta T is how much? 1.5, Kf is how much? 3.9, W2 I have to find out, M2 is 176 into 1000, W1 is 78. Now if I solve this and I find the value of W2, I will be getting 5.28 gram. So you have to write down here W2 is 5.28 gram. Clear? Next, question number 42. Heptane and octane form an ideal solution, okay. At 373 Kelvin, the vapor pressure of the 2 liquid components are given to me, okay. So I will write down here, for example, one second, heptane, P naught of heptane is how much? 105.2 kilopascal, okay. Then I have P naught of octane, which is 46.8 kilopascal, okay. Next I have calculate the vapor pressure of the solution containing 26 gram of heptane. So I will say W heptane is 26 gram and W octane is 35 gram, okay, clear. Now what I can do, I will calculate the molar mass of heptane first, okay. So if you see, heptane formula is C7H16, right. So it will be around 100 grams per mole, okay. Now molar mass of octane, if I see, it is C8H18, right. So 12 into 8, 96, 96 plus 18, 96 plus 18. So that will give me 114, right. So I will do this one, 114 gram per mole, okay. Next what I have here, I can calculate number of moles of heptane, that is given mass by molar mass, 26 by 100, and I can also calculate here number of moles of octane, that is 35 by 114, okay. That is moles and here it is moles. Next what I can calculate, mole fraction of heptane, that is number of moles of heptane by number of moles of heptane plus number of moles of octane, which is equal to 26 by 100 divided by 26 by 100 plus 35 by 114, okay. So you have to solve this, and this value you will be getting around If I solve this, I will be getting around 0.458. Now from here I can easily calculate the mole fraction of octane, that is 1 minus 0.458, and that will be equal to 0.542. Okay, clear? Now I can calculate the total pressure. Total pressure is equal to what? P naught of heptane into mole fraction of heptane plus P naught of octane into mole fraction of octane. What is the P naught of heptane value? 105.2. Okay, and what is the mole fraction of heptane here? That is 0.458. Okay, now plus P naught of octane is 46.8. okay, and P naught of octane here, that is mole fraction of octane, is 0.542. Now if I solve this, okay, how much we will get is around 73.56 kilopascal. Okay, so I have to solve this and check the calculation. So here the calculations are little lengthy, you have to be very careful and do it. Okay, next question number 43. The electrical resistance of a column of 0.05 mole liter inverse, concentration is 0.05 mole liter inverse. Okay, NaOH solution of diameter 1 centimeter. So what will be the radius? 0.5 centimeter, and we can calculate the area from here, pi r square, it is 3.14 into r square, 1 by 2 into 1 by 2. So it will be 2 1s are 2, 5.7, and if I calculate here, I will get 7.785, I think. Yes, 0.785 pi r square I got. Then length is 50 centimeter. Obviously length is 50 centimeter, and the resistance is 5.55 into 10 to the power of 3 ohm. Okay, calculate its resistivity. So we have this formula, R is equal to rho into L by A, or resistivity is what? Rho. So I can write resistivity as, resistivity is equal to R into A by L. Okay, this is my formula. Now if I substitute resistivity, R is 5.55 into 10 to the power of 3, area is 0.785, and L is 50, right? Now if I solve this, I will get the what? I will get the resistivity value. So if you solve this, you will be getting around, that is 87.2 ohm centimeter. You can check the calculation. Okay, now next one is to calculate the conductivity. Conductivity is 1 by rho, so 1 by 87.2, and that will be your, you will get 0.0115 s centimeter inverse. Next, the third one is to calculate molar conductivity. It is kappa into 1000 by C. So kappa is what? We have just calculated 0.0115, 1000. C is how much? 0.05, right? Yes. So if I substitute this, I will be getting 230 s centimeter square mole inverse. Okay, so you can just check the calculation, we will be getting around these values. Okay, some small difference is there in the decimal points, that is fine, but overall answer should be equal to or nearly equal to these values. Okay, next, calculate the Gibbs free energy change and the equilibrium constant for the cell reaction. This is very simple question. If you see Fe3 plus to Fe2 plus is undergoing reduction, so this has to be cathode. I minus to I2 is undergoing oxidation, so this has to be anode, right? So what is E naught of the cell? Is equal to cathode minus anode. Okay, now cathode value is your 0.77, anode value is 0.54. Okay, yes, so I will get here the value is 0.23. right? Now if I want to calculate the delta G value, that is equal to minus NF E naught of the cell. Now if I want to substitute the values here, you can see Fe plus 3 to plus 2 is 1 electron, but we have 2 Fe, so 2 electrons. Similarly, I minus 2, I2 also 2 electrons, so N value is 2. F I know 96.500 coulombs per mole, okay, and like E naught of the cell I got is 0.23 unit should be written volt. Now if I solve this, I'll get the delta G value as you can see here 44.39 minus 44.39 kilojoule per mole. Okay, this is done. Next, if I want to calculate the K value, so we have this formula, E naught of the cell is equal to minus, not minus, 0.059 by N log of K, right? Let me substitute here. This is 0.23. Here I have 0.059, N is 2, and I have log of K. So now if I solve this, then I'll get 0.23 into 2 by 0.059 is equal to log K. Now after solving this and taking anti-log, you will get K value as 6.251 into 10 to the power of 7 here, okay. Next, question number 45, the rate of a reaction quadruples when the temperature changes from 293 to 313. Okay, so I can say that if K1 is equal to X, then K2 will be equal to 4X. Here the temperature T1 is 293 Kelvin and the temperature T2 is 313 Kelvin, right? Calculate the energy of activation of the reaction assuming that it does not change with the temperature. So we can easily use our equation here, log K2 by K1 is equal to EA by 2.303 into R, I don't have to put into here, you can just write down 2.303 R into T2 minus T1 by T1 into T2, okay. Now if I write here log of K2 by K1 means 4x by x, 4x by x is equal to EA, I have to calculate 2.303 into 8.314, okay. Next T2 is 313 minus 293 divided by 313 into 293. So if you solve this and calculate, you will get EA value as 52.8 kilojoule per mole, okay. Clear? Okay, this is also very simple and direct question. Now moving to the last question. A reaction is first order in A and second order in B. Write the differential rate equation. So you can easily write it is like R into K into A into B square, right? First order in A and second order in B. How is the rate affected on increasing the concentration of B 3 times and decreasing the concentration of A by 2 times? So let us do like this, R dash is equal to K into, you have decreased the concentration of A by 2 times and increase the concentration of B by 3 times, okay. So I can write like this, 9 by 2 into K into A into B square. So I can write R dash is equal to 9 by 2 into R. So I can say that whenever you do this, the rate of the reaction will increase by 9 by 2 times. This is your first one, second one, and here I am doing the third one now. How is the rate affected when the concentration of both A and B are tripled? So I can write like this, A is also tripled, right? So it is 3A and B is also tripled, 3B square. So I will get 3 3s are 9 3s are 27K into A into B square, or I can write it as 27R. R dash is equal to 27R. So yes, the rate increases by 27 times, here the rate increases by 9 by 2 times, and the differential rate equation is this one, okay. Yes, so that's all in this paper, students, and I feel that the paper level was little bit on the tougher side because the questions were not very direct. As you can see, like the preparation of K2Cr27 was given in such a twist manner that you will think for some time. So but do not worry, nothing will come outside of your book, so please prepare your book properly. Everything written in a book is important, do not ignore anything, and if you have any doubt in any question, you can put down in the comment section. I will definitely address. Okay, so thank you for watching, and please do not forget to subscribe the channel, and all the very best for your exam.